Okay, you made it to the far side of the series. This is going to be the last one in the series of how to use a visualization method for doing the integration or calculus in general. But this one is integration by parts. And it's really pretty, actually. You'll notice that this function here can't be combined at all. It looks a lot like the product rule, doesn't it? If you want, you can see that the product rule is the basis for this particular method. So with that in mind, and I'm assuming that you know the method somewhat so far, let's get cracking with it. We have to pick one that we integrate and one that we differentiate. And these are cyclic functions here. We've got the cosine, we've got the e to the x's. They're things that are never going to reduce. If you know what I mean by reducing, if not, I can make a video. Just send in the comments if it's something that you have a question about. 2x is something that's going to reduce, okay? Because when we differentiate this, it's going to go down in order and then eventually a number and disappear. So that's what we're looking for. We're going to pick the one to differentiate as 2x. So that's going to be u. And then the one that we are not going to differentiate, the one that we would class as already a derivative, which is dv over dx, but I can call it v dash, is going to be cosine. How does this fit in with our table? Same thing going on with the table. We have our u, which always goes in the top left, and it always gone there. We have u dashed, and if you do look at the formula ever, you'll realize that in the formula it contains u and v dashed, and u dashed. The point being, we need all those elements. I like to put what is in the original question up the top, even though technically it's v dashed. We've had v dashed down the bottom. The two elements that are in the actual question go across the top here. So if this is v dashed up here, we have cosine x, and we're going to call that a derivative. That means we're going to find the antiderivative. That means integrate. If we're going to go here, and it's not going to have the derivative like that. So bearing in mind that moving down here, we're integrating. Cosine is going to go to sine, and differentiating here, we get 2. Okay, so we've got all the elements that we need here for our formula. Now, the question is, how do we apply the formula? I'm going to simplify it to just 2 multiplications and a takeaway. And we need to know what we're doing first. If you have any idea of the formula, if you bear that in mind, we have the uv first. And where are we getting uv from? Top left down to the bottom, right? So we're going to go down that way. It's those two. And then we're going to subtract. And then we're going to have some sort of product between the v and the u dashed, and the v and the u dashed are these two here. So we've got some sort of swooping motion. Okay, so we're going to go here first, and then it's going to be these two second. I just got myself used to drawing this table. The two elements go where they go, just like every other method. It's those elements in the question, and I work like a swooping, like a diagonal and left, and that's all it is. I'm remembering like a symbol. So let's put it into action. We have to do this one first. Okay, so 2x cosine x, that's going to be 2x sine x, subtract the integral of, now we're coming back for this one, that's going to be 2 times sine x. Okay, we are in a good position. What I want you to note, just for fun, is that our original 2x here has been reduced to a 2. The original question, we had a 2x in front, now it's a 2. Okay, the other thing that's changed is it's a sine instead of a cosine, but this reduction has allowed us to actually answer this question properly. In final, no, let's take 2 lines. We've got sine x, subtract 2 integral sine x. I always take the integrating factor out. Somehow, it just, I vibe with that, you know, it works for me to see it a bit more clearly. That 2 is coming out, and the result of the integral of sine x. So what's that going to be? So negative cosine x, right? We do plus c at the end for everything. And we're going to tie this up. So we've got 2x sine x, and those two negatives are going to be best of friends, and we end up with cosine x in the positive. That's it. So we'll go back to our original question, and we've completed the integration by parts without using the formula, really. We're more using visualizations to help us remember the structure of what we do with the elements. Let's see if we can repeat that and if it really sticks and helps us with some practice. If you click at the link at the end of this video, you can get to the practice questions, and I'll see you on the other side. If you want to support this channel, head on over to Patreon. You can get extra resources and a free gift with every sub.